My dear students, today I am going to discuss physics for class 10, the chapter of electricity. In this chapter, there are very important concepts like charge, potential difference, Coulomb, ampere and all that. So let me discuss those important things, okay? And one or two numerical problems. Now, first of all, let us say what is charge. Now, charge is a condition, is a property of a substance, all right? Now, protons are said to possess positive charge and electrons are said to possess negative charge. Now, if a body has equal number of protons and electrons, if a body has equal number of protons and electrons, then we say that body is neutral. So, number of proton is equal to number of electron. If a body has equal number of protons and electrons, that body is neutral, that means uncharged. Because proton positive charge, electron negative charge, so they neutralize each other if there is equal number. But if there are greater number of protons than electrons, if a body has greater number of protons than electrons, then it is positively charged. It is positively charged. So this body is neutral. So if there are equal numbers of protons and electrons, that body is neutral. But if there are greater number of protons and fewer number of electrons, number of proton greater than number of electron, that body is called positively charged, because proton is positively charged, all right? But if there are number of electrons greater than number of protons, then it will be what? Negatively charged, because electrons are negatively charged. So if a body has greater number of electrons than protons, that body is negatively charged, all right? So a charged body means it has either excess of protons or excess of electrons, all right? Now, this charge has been quantified. Now, actually charge is although it is a property or condition, now it has been given a unit, therefore it is considered as a physical quantity. Now, in order to consider it as a physical quantity, scientists have done this. So, what they have done? Scientists have considered 6 into 10 to the power 18 electrons. So, total charge of so many electrons, they have called 1 unit of positive charge, 1 unit of charge. All right. So, in order to quantify that charge, although it is a property, in order to give it a definite unit, so call it a physical quantity, the scientists have done this. So, they have considered the total charge of so many electrons is 1 unit of charge, 1 unit of charge. Now, obviously, it will be 1 unit of negative charge. But if you say 6 into 10 to the power 8 protons, total charge of same number of protons, so that will be equal to 1 unit of positive charge, 1 unit of positive charge. So whether it is positive charge or negative charge, this number is important. It's approximately so many electrons, the total charge of so many electrons has been given the name 1 unit of charge, and so many electrons of proton also 1 unit of charge. So this number. So that is how we get a unit charge. Now when you say unit charge, we mean total charge of so many electrons. Usually in definition, we do not use protons. We do not use protons because protons are confined in nucleus, they cannot come out. But electrons are revolving around the protons. In class 9 you have learned. So this is why in the definition we never use the term proton, we always use the term electron. So how will you define 1 unit of charge? that is the total charge contained in so many electrons, 6 into 10 to the power electrons. It is a huge number, 6 and 18 zeros. You follow? Such a big number of electrons together make 1 unit of charge, and this unit has been called a coulomb. So coulomb is the SI unit of charge. So when you say 1 coulomb of charge, we mean the total charge of so many electrons. And from here there is a calculation you will find. So therefore one electron has what charge? One electron has charge 1.6 into 10 to the power minus 19 electrons, minus 19 coulomb. So many electrons have a charge of 1 coulomb, and therefore what is the charge of just one electron? The charge of one electron is 1.6 into 10 to the power minus 19. So small, you see, 1.6 divided by 10 to the power 19. So small amount of coulomb. That is the charge of one electron, or you can say that is a charge of one proton, because a charge of one proton and one electron always equal, isn't it? So this is the concept of charge and SI unit of charge. SI unit of charge is what? Coulomb. Okay. All right. Now let us go to the next important term, this potential. Potential. Now before potential, you have to know one term, electric field. Electric field. Electric field. Now there is a term magnetic field. Similarly, there is this term electric field. Now a magnet has a zone of influence around it in space. Suppose this is a magnet. This is a magnet, North Pole, South Pole. Now this magnet has a zone of influence around it. That means within this zone. Now this is in the board I have drawn. It looks like a plane, but it is not plane. It is in space, a zone, a region in space. So around the magnet there is a space zone inside which the magnet can attract things or repel things. So that is called magnetic field of this magnet. Similarly, if there is a charged body, suppose this is a charged body, positively charged body at the center. Now around it there is a zone or space inside which this charged body can attract a negatively charged body or repel a positive charged body. Now between positive and positive there is repulsion, or between negative and negative there is repulsion. Between positive and negative there is attraction. So like charges repel. Between positive charge and positive charge repel each other. Negative charge and negative charge repel each other. But positive and negative they attract. All right. Now this is a positively charged body. Around it, it has a zone of influence, a space inside which this positively charged body can attract a negative charge or repel a positive charge. So this is called electric field. Just like a magnet has a magnetic field. All right. Now, so how will you define electric field? So electric field is the zone or space, region. You can use these words. So electric field is the zone or region or space around a charged body, inside which the charged body can attract or repel another charged body. All right. So that is electric field. Now, in order to understand potential, we have to have this idea clear, electric field. Now say this is the electric field of this positively charged body. This is a positively charged body. Now this is the electric field. Now consider here unit positive charge. So when you say unit positive charge, we mean 1 coulomb of positive charge. When you say unit positive charge, unit means 1. Unit positive charge means 1 coulomb of positive charge. So capital C is a symbol of coulomb. So coulomb is the SI unit of charge, already explained. Now suppose this is unit positive charge, that means 1 coulomb of positive charge. Now this is positive charge, so naturally there will be repulsion. So this will repel this, isn't it? Now this is just outside, this outside the zone of influence, outside the electric field. Therefore, this is not experiencing any force. It is not under the influence of this body because it is just outside the electric field. Now, suppose you want to bring it towards the central positively charged body into the electric field. Then some work has to be done. In order to push this unit positive charge towards this positive charge, you have to do work, because if it is coming this way, then this will repel, because positive repels positive. So a work has to be done in order to bring this towards this. Suppose we have brought this up to this point A, doing some work W. Suppose W is the amount of work done to bring this unit positive charge from this point. This is called position of infinity. Just outside the electric field, we say it is infinity. So from infinity up to the point A towards the central positive charge, we are bringing this, pushing it. And what work is done? W. So this W will be called potential at A. So potential at A. So potential at A, this word, potential at A is the amount of work done to bring unit positive charge from infinity, that means outside the zone, outside the field, from infinity up to that point. So what is potential at A? Again, potential at A is the amount of work done to push, to move unit positive charge, that means 1 coulomb of positive charge from infinity, that means from just outside the field into up to that point A. All right. So suppose this one A. Now you want to bring it further. You want to bring further towards, suppose, this point B, just near the charge. Then you have to do more work. So from here to here, you have done what amount of work? W. And from here to here, suppose you say this is W1 and say this is W2. To push the unit positive charge from infinity up to this point, what work is done? W1. And further, to push it further up to the point B towards the central positive charge. So another amount of work done, and suppose that is, this is what you call, from here to here W, from here to here W1, and from here to here W2. Okay. So definitely W2 is greater than W1. So this difference, W2 minus W1. So this will be called potential difference between A and B. So from infinity up to A, what work is done? W1. Then some more work is done to push it from A to B. Now from infinity up to B, suppose the total work done W2. From infinity up to A, work done W1. From infinity up to B, up to point B, work done W2. Now W2 minus W1, this difference is called potential difference between A and B. So how we define potential difference between 2 points in an electric field? The potential difference between any 2 points in an electric field is the amount of work done to bring unit positive charge, that means 1 coulomb of positive charge, from one point to the other. So again, let me tell you, potential difference between any 2 points in an electric field is the amount of work done to move unit positive charge, that is 1 coulomb of positive charge, from one point to the other. That means W2 minus W1. So this is potential difference. All right. Now suppose this okay, now suppose this one, suppose here we have q coulomb of positive charge. So this time let us say there is a charge here, amount is q coulomb of positive charge, not unit, not 1 coulomb, not unit positive but q coulomb. All right. Now to bring it to this point, suppose A, the amount of work done is W joules. In class 9 you learned the SI unit of energy and work is what? SI unit of work and energy is joules, isn't it? So from the point of infinity, up to point A, you are moving q coulomb of charge, and amount of work done is W joules. Have you followed? So for q coulomb, see, for q coulomb amount of work done W. Therefore, for 1 coulomb amount of work done, isn't it, by W by Q unitary method. To move q coulomb of charge, amount of work done W joules. Therefore, to move 1 coulomb of charge, amount of work done will be W by Q. All right. So this W by Q will be potential at A. So this will be potential at A. All right. And this potential at A, so this potential, this is the SI unit is volt. All right. So we get a formula. See what formula we get? Potential is equal to what? Work, W work by charge. Work by charge. So this is one difference. This is one formula we get, potential. Now, suppose suppose this point was A. So this point A, and like the previous discussion, this point is B. Now potential difference between A and B will be same, work by charge. Potential difference between A and B will be what? The amount of work done to move that charge from A to B, isn't it? So potential difference unit formula also will be same, that is this one, potential difference equal to work by charge. All right. Therefore potential difference SI unit will be this. What is the SI unit of work? Joules. And SI unit of charge? Coulomb. That means joule per coulomb, JC minus 1. This is the SI unit of potential or potential difference. The potential or potential difference, the SI unit is what? This is work by charge. Work is joule, charge is coulomb. So joule per coulomb, JC minus 1. And this has been given the name, just one word, volt. This volt. So when you say volt, we mean joule per coulomb. And volt is the SI unit. Volt is the SI unit. SI unit. Now SI unit you have learned right from class 8. You know what is SI unit. So volt is the SI unit of potential difference. Right? So this is the whole picture about potential and potential difference. Now I have discussed the potential difference with respect to an electric field. Now let us see potential difference with respect to a circuit, with respect to an electric circuit. Now, so electric circuit contains a source of current, suppose a battery, all right, and a resistor. Suppose resistor, then this battery. Yeah, suppose this is the electric circuit, all right, electric circuit, and suppose this is positive charge, negative. Let me draw a little bigger. Okay, so all right, suppose this is a thing. Okay, so in simplicity, this is the circuit. Now this is, suppose this is positive terminal, this is negative terminal. Now a battery has two terminals, positive and negative, isn't it? So this one positive, this side positive, this side negative terminal. All right. Now this is a resistor. It may be a bulb, it may be a fan, some electrical equipment. Okay. Now, so now let us call this positive terminal, say point A, and negative terminal point B of the battery. So point A is the positive terminal, B is the negative terminal. Now when you connect positive terminal and negative terminal by this wire, that external circuit, then current flows this way, isn't it? So current always flows from positive to negative, right? Now this battery or source of current has a potential difference or voltage. Suppose this is 12 volt battery. 12 volt battery. Now 12 volt means what? 12 joules per coulomb by 1 coulomb. That means to move 1 coulomb of charge, 12 joules of work is done. So now charge, this battery is pushing charge this way through this bulb. This is why the bulb will glow. Suppose this is a bulb. The bulb will glow because this battery is giving current to the bulb. The battery is pushing the current. The battery is doing the work of pushing the current. Alright. Now battery is doing work at what rate? 12 joule per coulomb. So to push 1 coulomb of charge, the battery is doing 12 joules of work. This is why the voltage of the battery, potential difference or voltage, this is another word. You can use the word potential difference or voltage. So potential difference or voltage of the battery is 12 volt. That means the battery is doing 12 joules of work to push 1 coulomb of charge from this point A to point B. Charges always flow from positive terminal to negative terminal. So remember, positive terminal is at higher potential. Positive terminal is at higher potential. And negative terminal is at lower potential. Positive terminal is always a higher potential of a battery. Negative terminal of a battery is at lower potential. So just like heat flows from higher temperature to lower temperature, heat energy always flows from higher temperature to lower temperature. That way, electric current or charges flow from higher potential to lower potential. Higher potential means positive terminal, lower potential means negative terminal. So this is how charges are flowing. Now, who is making the charge flow? This battery. So battery is doing the work. If it is a 12 volt battery, that means it is doing 12 joules of work to push 1 coulomb of charge from this positive terminal to the negative terminal through this bulb. And this is why the bulb is glowing. If it is a fan, the fan is working because current is passing through the, charges are passing through the bulb, through the fan, through the iron, etc. Alright. So now potential difference between A and B is 12 volt. So in a circuit, how potential difference is defined? So potential difference between any 2 points in a circuit is the amount of work done to push unit positive charge from one point to the other. Now suppose you consider this terminal of the bulb. Now bulb, fan, fridge, they all have 2 terminals. Okay? So this is positive terminal of the bulb. Suppose this is a bulb. This is positive terminal because it is connected to positive of the battery. This is negative terminal because it is connected to negative of the battery. Now between this positive terminal and negative terminal, the potential difference is this 12 volt. So this 12 volt is a potential difference of the battery. So same 12 volt will be potential difference between the 2 terminals of the bulb, fan, fridge, whatever. Okay. Therefore, suppose this point is P, this point is Q. So potential difference between P and Q is what? How will you define? Potential difference between these 2 points P and Q is the amount of work done to push unit positive charge from point P to point Q, from one point to the other. So potential difference you have to define 2 ways. Potential difference with reference to electric field. So what was that difference? Potential difference between any 2 points in an electric field is the amount of work done to move 1 coulomb of unit positive charge. To move unit positive charge, that means 1 coulomb of positive charge from one point to the other. Now in case of circuit, how will you define? Potential difference between any 2 points in an electric circuit is the amount of work done to move 1 coulomb of charge, that means unit positive charge from one point to the other. Alright. So this is how you give the definition of potential difference with respect to electric field and or with respect to circuit. Okay. Okay, so this is the thing. So now what we have got? We have got this potential difference. There is a formula. Symbol is volt. Symbol is V. So that is equal to what? Charge symbol is Q. Sorry. So work done. The symbol is W, and charge, that is Q. So one formula you have seen, potential difference V equal to W by Q. This is the formula. Now with regard to SI unit, this will be volt. Now volt, potential difference and volt, the symbol is same, V. So V equal to W work SI unit is J, and this is Coulomb C. So V equal to J C minus 1. So volt, this V means volt. So SI unit volt equal to joule per coulomb. Okay. All right. Now just we'll finish with one numerical problem. So let's say one numerical problem. Suppose now another thing before we do that, dry cell. Now your torchlight battery, that pencil torch battery, torchlight battery, that is dry cell. And dry cell, if you note, there is a label, and on the label it is written what? 1.5 volt. So in a dry cell, the potential difference is 1.5 volt. Now just let me draw this, suppose roughly this diagram. So this is a dry cell. Now details about dry cell, I think you have studied in class 7, 8 or 9, all right? Now dry cell, this is a positive terminal, and this container is the negative terminal, all right? Now between positive and negative, so there's a 1.5 volt. This is the potential difference of a dry cell. Now in the exam, sometimes they ask you a question. Potential difference of a dry cell is 1.5 volt. Explain. Or what do you mean by saying potential difference of a dry cell is 1.5 volt? All right. That means if you connect this positive and negative terminal, suppose through a bulb, if followed, then electricity will flow, charges will flow from positive terminal to negative terminal. All right. And then who is pushing the charge? The battery. Now when you say battery, the chemical reactions of the battery. The battery is pushing the charge. At what rate? 1.5 volt. That means 1.5 joules per coulomb. So to push 1 coulomb of charge, this battery is doing, this cell is doing what work? 1.5 joule. So 1.5 volt means 1.5 joule per coulomb. 1.5 joule per coulomb. That means 1.5 joule per coulomb by 1 coulomb. So to push 1 coulomb of charge, this battery is doing what work? 1.5 joules. And that charge, when passing through the bulb glows. All right. So this is the meaning of saying that dry cell has a voltage, potential difference or voltage. How much? 1.5. Sometimes it is asked. Okay. All right. This is all for today. I hope this discussion is benefited. Is benefiting you. Okay, then today I'll wind up here. So in my next video, I'll show you some numerical problems and other units related to this. Okay, thank you.